Hey guys, so this is a quick video, well, as quick as possible on 3A and 3B homework. So starting with 3A, the topic for 3A was solve quadratics by factoring. So basically you're asked to two things. First factor and then solve in that order. In example 1, I think this here was example 3, let me write it on the side, 6n squared minus 18 minus 18n minus 18 equal to 6. And cross it off from here. So in the first example, you're already given a factored form, right? You have 4k plus 5 in parentheses, that's a factor, and then k times k plus 1, another factor, equal to 0. How do we solve? What does it mean to solve? Solve means find the variable, find x or find k, right? Find what x is equal to, or find what k is equal to, depending on the variable. So in this case, in number 1, we want to apply the zero product property. Okay, and the zero product property says, if you have, here for this class we use two terms, right, two factors, multiplied that give you 0, then either the first one is equal to 0 or the second one is equal to 0. And we can extend this property. It could be a times b times c times d, etc., equal to 0. That means one of them must be 0. So in this case, what we're saying either 4k plus 5 is equal to 0. And to solve for that, to get k by itself, you need to subtract 5 from both sides to get 4k equals to negative 5, and then divide by 4, which gives you k equals to negative 5/4. So this is one solution, right, one answer, and then or it's k plus 1 that is equal to 0. So remember, we're saying if we're multiplying two things and getting a 0, then either the first thing, the first item here, which is 4k plus 5 is 0, or the second item, which is k plus 1 is equal to 0. And then now we're solving for k plus 1 equal to 0, which by subtracting 1 from both sides, we get what? We get k equals negative 1. So these are our two solutions, all right? This is by the zero product property, and they already factored this out for us. So they, it was less work. We only needed to solve. Now for number 2, we don't have a factored form. In fact, not only we don't have a factored form, we have a number on the right-hand side. And this number, according to classwork, the lesson, we said that we cannot have equal to negative 5 or equal to any number for this case. Therefore, we need that gone. And we need a 0 on the right-hand side. So to do that, we have to add 5 to both sides of the equation. And the 5s and the negative 5 cancel out, give me 0. And I'm left with x squared minus 11x, and 19 plus 5 is plus 24. And now we can factor. So only until we have equal to 0 on the right-hand side, only then we can factor. Now let's factor. So we can use one of the methods we learned in the previous unit. So the previous unit basically helps you factor, and this unit helps you solve once you have the quadratic in the factored form. So now we're asking ourselves, what two numbers multiplied to 24 add up to negative 11? And we know negative 3 and negative 8 do that. So we have x minus 3 quantity multiplied by quantity x minus 8 equal to 0. And therefore, by the zero product property, it's either that x is equal to 3 or x is equal to 8. Now you can write it in this form, or you can also write x equals 3 comma 8. That means 3 or 8 do work. For number 3, we have a 6 on the right-hand side, so we only need to subtract 6 from both sides, and this gives us 6n squared minus 18n minus 24 equal to 0. Now, if you recall when we started the factoring unit, which is the previous unit, right, we always said it's great or it's best that we try to factor a GCF whenever a GCF exists. So in this case, we look at 6n squared, negative 18n, and negative 24. And we can see that 6 is actually the highest common factor or the greatest common factor. And this leaves us with n squared minus 3n and then minus 4 equal to 0. And now we can factor only this portion, which should make it easier, because with this, we know that we can ask ourselves what two number multiplied to negative 4 and add up to negative 3. We know 4 times 1 gives us 4, but we want the sum to be negative. Therefore, the largest value would have to be negative, here negative 4. So this gives us 6 We copy the 6 down and then multiply by quantity n minus 4 and then quantity n plus 1. Now, this is the factored form. This is the factoring part. Now we do the solving part. So solve means find the n values that make these 0. We know n equals -1 does, and n equals +4 does. So again, I just showed you a different way of writing. Instead of writing n equals twice, you can also write it in this form is acceptable, and this form is acceptable. Now number 4 is, is also more of the same, except number 4 is a binomial. So we only have 2 terms. We can only factor here, you can see that only x can be factored out, and this leaves us with 7x plus 2 equal to 0. Now, some of us may be lost here because we've been looking at, factors with 2 terms every time. But don't worry, we're saying here x times quantity 7x plus 2 equal to 0, which means that either x is equal to 0 or 7x plus 2 is equal to 0. And by solving for x here, we subtract 2, we get 7x equals -2. And therefore, by dividing by 7, we get x equals -27. So these are our 2 possible values. Remember, we're saying this or that, right? And mathematically, or is, as we said in class, is an inclusive or. That means either the first is 0, the second is 0, or both of them could be 0. Both factors could be 0. Number 5, again, add 59x to both sides. Just be careful when you're adding and writing equal to 0. You need to make sure that your trinomial here, or your polynomial in general, is in standard form in descending orders of the exponent. So 8x squared, and then plus 59x, just be careful with that, and then plus 21, and that's equal to 0. And again, you can do the x method, or you can try to factor out. A lot of students like the x method. In this case, you're going to do it with a grouping. Most of you prefer that. I think almost all of you prefer that. So we can do what 2 numbers multiplied to 8 times 21 is 168, and it up to 59. And this is actually a large number, so you may not want to do grouping here and do it this way, but it's fine. So basically, we can try knowing like 1 and 168 is too far, 2 and 84 far, 3 and 56 should work. Okay, so technically now this 59x, if you recall, we can break it up into 3x and 56x. So we can write it as 8x squared this plus 56x plus 3x. That's where our 59x came from, plus 21 equal to 0. And then you can do grouping, 8x multiplied by, let me just clean this up a little bit, 8x multiplied by x plus 7 plus 3 times x plus 7. And remember, you anticipate, right, this happening here again. And therefore, ax plus 3, again, equal to 0. Don't forget that. 8x plus 3 multiplied by x plus 7 equal to 0. And therefore, now, here's what I want you to kind of learn this in a quicker way. We know for this, x is equal to -7. We already know this. It's pretty simple. The shortcut to when we have an a here that is not equal to 1, and then plus 3, the shortcut is you get x equals, instead of you setting it equal to 0 and solving, you can do the opposite of this. We talked about this in class, the opposite of this value over this value. So x equals what? -3/8. And this is our second 0 for this equation. Let's move on to the next question. Number 6 is very similar to, really, number 6 is similar. Let's check number 8. Number 8 real quick. So you can see it, x equals -1. That's one solution. And here again, if you do the opposite of -1 over 2, that's going to be 1/2. So these two are your solutions, right? How simple it gets. Lastly, in number 9, you have 3r squared minus 16r. Now we have -7. I'm going to take away 5 from both sides, right? Because I want the 0 on the right-hand side. So this becomes -12 equal to 0. And again, I try to see if I can factor a GCF out. There's no GCF. 3, 16, and 12 don't have anything in common. We call them relatively prime, so they don't have a number in common. They don't have a common factor except for 1. Therefore, we need to, let's try the x method again, because you guys prefer that. What 2 numbers multiplied to -36 add up to -16. 2 and 18 multiplied to 36. And I want the largest to be negative. So basically this becomes 3r squared minus 18r plus 2r minus 12 equal to 0. And then 3r times r minus 6 plus 2 times r minus 6 again. And that's equal to 0. And therefore our factors are 3r plus 2 quantity multiplied by r minus 6. And therefore our solutions, our zeros or solutions or intercepts are r equals negative 2/3. Remember, opposite of this over this, or 6. And again, I wrote it in a different format than previously. But they're all acceptable, like with a comma in between, or if you put or if you write it twice, they're all acceptable forms. So this is really homework 3A. Okay, I know the key is online, but this helps you understand how to go about it. So moving on from 3A to 3B real quick. 3B was on solving quadratic by graphing. So again, when you're solving, you're actually telling me where the solutions are. That means where does the graph of the parabola meet the x-axis, or maybe if it doesn't, it doesn't, right? So if the parabola meets at one point, something like this maybe, or like this, right? We call this one solution, and I would like these to have arrows here. If it meets at 2 points, something like this, maybe that would be 2 solutions right here. These are your solutions. And then if it meets at no point, so if your parabola is like this, it doesn't intersect the x-axis, right? This is the x-axis. If it doesn't cross the x-axis or something like this, then no solution. So 1 point of intersection, one real solution. 2 points of intersection, 2 real solutions. No point of intersections, no real solutions. Keep that in mind. For the homework associated with this part, the homework said the following. So the homework said solving by graphing. So x squared plus 4x plus 4. How many solutions, right? So we can tell, you know, we talked about the elements of a quadratic, the a, b, and c, and then the vertex. So we can tell by graphing where this is going to be. How do we go about it, right? So again, we're doing now 3b. We're doing for number 1. We know that the x value of the vertex, right, is at negative b over 2a. And this is critical for us to know, which means that our vertex, the x value of the vertex, I should say, it's negative 4 over 2 times 1, which is negative 4 over 2, which is negative 2. Now, if you forget, remember a is the coefficient in front of the x squared, which is 1. B is the coefficient in front of the x, which is 4. And then c is the constant, which is also 4. So negative b over 2a ends up being negative 2. That's the x value. To find the y value, we want f of negative 2, basically. We plug in negative 2 into the equation to get, remember, a good practice was erase the x value, erase the x, replace it with a pair parenthesis, and then plug in the number in. Plus 4 multiplied by negative 2 plus 4. This is a good practice to avoid making mistakes with negatives. Negative 2 squared is 4. 4 multiplied by negative 2 is negative 8. And then plus 4. 4 plus 4 is 8, minus 8 is 0. So negative 2, 0 is our vertex. So our vertex is right here. Again, given that, of course, the scale is by 1 here. So this is our vertex. And then we know, because A is positive, we have a happy face, right? Parabola, happy parabola. So we know that the parabola is going upward from this point on. We know that information. And therefore, because the parabola crosses the x-axis at one point only, namely here the vertex, we only have one solution. Okay, again, 1 point of intersection, 1 solution. What is the x-intercept? We just talked about that. We front-loaded that information. It's actually negative 2, 0. That's the x-intercept, which is right here, negative 2, 0. It happens to be the vertex. And then what is the y-intercept? Where does it cut the y-axis? Where does the graph meet or cross the y-axis? Now, for us to know this, for us to know when they ask you where's the y-intercept, that's basically when x is 0, right? When x is 0, the y value is the y-intercept. So all we are doing is getting rid of the x's. That's how you make the x's 0. Basically, you get 0 here, you get 0 here, and you're left with y equals 4. So 0, comma 4 is our y-intercept, which means my graph was a little bit poor here. I should have been a little bit more careful. 1, 2, 3, 4, right here. My y-intercept is here. So 2 to the right, 4 up. I'm going to also go 2 to the left. Remember, by symmetry, you can do that. 1, 2, 3, 4, you're here somewhere. And then what is the domain? So this is my y-intercept going this way. Remember, the parabola is a U-shaped smooth curve. Try not to make it pointy at the vertex, okay? It's a U-shaped curve. What is the domain? The domain is the x values. What are the x values, the acceptable x values? It's all real numbers from negative infinity to infinity. Remember, we always place negative infinity on the left because it's a lower value. What is the range, the y values? The y values, we start at 0 and we go up, including 0, because 0 is part of the graph. So we say bracket 0, comma, infinity. For number 2, that's pretty simple. For number 2, again, we're solving by graphing, right? So here, if we were asked what is the solution, if we're asked what's the solution is where the graph meets the x-axis. So the solution is -2, 0. Or you can say x equals -2, right? The 0. The 0 means the x value that makes y equal to 0, okay? So the words 0, solution or solutions, x-intercept, they all mean the same, okay? They all mean the same. I'll let you do number 2. I was going to do number 2, but I'll let you try to practice it using the same approach. So this is pretty much it on 3A, 3B. They're not difficult concept, really. They're just a variety of ways to solve. The first one, 3A, was by factoring. So you factor, you set equal to 0 and you solve. And 3B was just by graphing. That means you graph the function, and whatever it crosses the x-axis, these are your solutions. So I hope this was helpful. Try your best to pause, review, go back, rewind, and just, if you're still not certain about certain concepts, and just make sure you master them by the end of the video, okay? Remember these techniques, they're super, useful, and soon enough, you're going to probably have a quiz on them, so make sure you understand them well. Good luck to you, and I'll see you in class.